Next up, we have oral presentation 14, San Jose, California, Team 3, Mission 12 Flight Experiment.
Hi, I'm Amelia Lichei.
I'm Kimberly Way.
I'm Grace Farrell.
I'm Morgan Lord.
And I'm Natessa Wright.
We are 7th graders from San Jose, California, and we go to Discovery Charter School. Our teacher is Susan Leftwich. Our experiment examines the effect of microgravity on spider plant seeds, and will determine if a spider plant can successfully germinate in microgravity. We chose this experiment because scientists have found that indoor air pollutants are ranked among the top 5 environmental risks to public health, and living and working in places rife with air contaminants can cause dizziness, headaches, nausea, and can eventually lead to cancer.
Since these chemicals are even more prominent in space and on the ISS, there's an even greater risk for astronauts to be exposed to these illnesses. However, spider plants would reduce up to 90% of the formaldehyde, carbon monoxide, O-xylene, and P-xylene, which would dramatically purify the air. Therefore, our findings would greatly benefit the health of future astronauts, as if the test is successful, meaning that the seeds would have germinated, we could plant spider plants in microgravity and the air quality in space would get significantly better.
To test our idea, we are sending 8 spider plant seeds into space along with distilled water that is enhanced with a fertilizer. This fertilizer will help to increase the rate of growth of the seeds, as spider plant seeds usually take about a month to germinate. We wanted to ensure that the amount of time wouldn't be the reason why the seeds don't end up germinating.
In volume 1, we put 4 milliliters of distilled water diluted with fertilizer. Although tap water is more accessible, we chose to use distilled water in this experiment because some tap waters may contain chemicals such as chlorine, which can damage the plant during germination or cause it not to grow. The process of distillation ensures the plant's safety during growth.
Volume 2 holds 8 spider plant seeds. We are sending up more than 1 seed because of the possibility of failure from 1 or more of the seeds. With 8 seed, it increases our chances since it is more likely for at least 1 of them to grow. However, it isn't enough seeds to crowd the tube, which makes it a perfect number.
The growth inhibitor is placed in volume 3. This growth inhibitor is a solution that is 4% formaldehyde and 96% water, which doesn't contain so much formaldehyde that it could damage the seeds, but also enough to completely stop its growth. This growth inhibitor will stop all seed germination and freeze the seed's germination process so that we can observe what happened to the seeds when they return to Earth. This is significant because it makes sure that whatever results we eventually get happen only in microgravity, so that the spider plants don't continue to grow when the conditions change.
In order to prepare the FME for the ISS, we placed the 8 spider plant seeds, distilled water, and growth inhibitor in their respective volumes. No refrigeration is needed in this entire process, making it fairly straightforward to conduct. The day of the arrival on the ISS, an astronaut will unclamp clamp A, allowing the seeds and the water to combine. The astronaut will then gently shake the tube for 5 seconds so that it is certain that the seeds and water are completely mixed. Assuming that everything goes smoothly and as expected, the seeds will begin their process of germination.
It could take up to 2 weeks for the sprouts to become visible, so we wanted to give them as much time as possible to grow in microgravity. 2 days before our mini-lab returns from the ISS, an astronaut will be asked to unclamp clamp B, mixing the growth inhibitor with the germinating seeds and interrupting the germination process.
When a seed is exposed to its proper conditions, water and oxygen are taken in through the seed coat. The embryo's cells start to enlarge, followed by the seed coat breaking open, and finally, the emergence of a radicle. This is the process of spider plant germination on Earth. As said, we will also be conducting the identical experiment in microgravity, so that we can compare both results to detect any possible differences. If in fact there are any differences between the seeds, we would examine them closely to see if they are in an unhealthy state.
For example, if the radicle doesn't even emerge on the ISS, then this probably means that microgravity had some effect in it and caused the germination to be irregular. We would thoroughly research and examine them if this were to happen.
However, if the seeds weren't able to even germinate, we would first conclude that spider plant seeds are unable to germinate in microgravity, but also inspect them and research them to find out why this happened and what exactly made this process unsuccessful.
Nevertheless, if the spider plant seeds were to successfully germinate in microgravity, we would therefore conclude that spider plant seeds are able to thrive under the conditions of microgravity and could possibly purify the air in space.
We would like to thank Discovery Charter School, Subaru of America, James Wright, and Susan Leftwich for supporting and financing this project so that it could be made possible. Thank you.
Do we have any questions for this team? Okay, wait, we have one coming.
Suzanne, Stamford, Connecticut. Nice job, ladies. I know you used the spider plant as a reason. Only the spider plant, you talked about the fact that it can be taking all the pollutants, and then if they're able to make it grow, we worried about the pollutants that then can come back as well.
Could you clarify that question, please?
Sure. So you chose a spider plant over any other just because of their ability with pollutants to purify? Why did you choose a spider plant?
Well, we chose the spider plant because it can reduce different chemicals that are prominent in space and on the ISS that can be proven to cause nausea and cancer and different health problems for astronauts, and we were really concerned about astronauts' health while in space, and so that's why we found the spider plant and we kind of chose it because we wanted to help astronauts.
Do we have any further questions?
Why choose 8 seeds instead of any more or less?
Well, we chose 8 seeds because we were worried that if we had only sent up 1 or 2 seeds, they might have not germinated. So we figured the more we send up, the more likely they are to germinate, or at least 1 seed will germinate, hopefully.
And why not any more seeds?
Because we were worried that if we sent up any more, it would overcrowd the tube.
Thank you.